Hi, this is Chong Kim, and we're going to do word search in Ruby. Okay, let's take a look at the input. So we're going to start off with a block of text that looks like that, and a list of words. And we see that there's a question mark here, and that represents a wildcard character, so it could be any character. All right, so let's start. I'm going to do this without using any test. It's going to be a short script, but we're going to be testing along the way anyway, even if it's not a formal way of testing. So let's start. Alright, first thing we're going to do is modify Vim so that when we save the file, it's going to run this automatically. And we can do that by doing AU. The exclamation point is to override if there was an already existing definition. For buff write on post. And the file pattern, we'll just do it for the word search.rb. And the command is we go into the shell. That's what the colon bang means. And we will run ruby word search.rb on the input.txt. Actually, let's do .input.txt because it's the directory one below. Okay, so first let's see if it actually works. So we're going to print hello, save, and there it is. It says hello. Great. Okay, we're going to read the file, argf. Read. That should read in the file, and let's check to see if that is working. We just put s, and it is. So we have the file. We need to split it up into two parts. Well, let's take a look at that output again, or our input. We see that it's separated by two carriage returns, carriage return, so blank line. So we're going to split on carriage return, carriage return. Okay, and we're going to capture it in two variables. One is the grid string and the word string. Okay, so on the grid string, we're going to store it in a data structure that looks like we're going to take a row and column followed by a character. So it's a nested set of lists. And we're going to have a list of these. So let's see. We're going to have a list of it that looks like this. And we're going to have a list of those for each row. So it's going to be quite an embedded list of lists. Okay, so let's start with the grid S. So we need to, this is one long string for now, so we're going to split it on a new line. So now it's a list of lines. Okay, let's print it out along as we go along. Okay, so it's a list of lines. And we're going to do a map with index because that's how we're going to get the row number. So that will give us a line and the row. Okay, and let's return, we don't quite have it yet, but it will be something that looks like a row and column. We don't have the columns, so we'll just put 0 in there for now. And then it's going to be line. We don't have a character yet, so we'll just substitute the line in there. And okay, so we're getting closer to what we want. Okay, this thing's starting to get long, so I'm going to wrap this around. Okay, now we're going to take the line and we're going to do the same thing. We can do map that with index on the line, and that should return the character and the column. Okay, and so now we can actually replace the 0 with the column because we know the column now, and we can also replace that with the character. Okay, this isn't going to work right now because line doesn't work with map. It'll complain because we need to convert that to chars, a list of characters. And there it is. Okay, so we have the first part. So it's a list of lines. Okay, so this takes care of the first part. So we'll call this grid line. Okay, grid line. Okay, and another thing that would be very useful is to turn this into a grid. And the way the grid is defined is basically the same thing as grid line, except that it's not separated into a list of lines. It'll be just a okay. So this is what it would look like. A grid you would index it by the row and column information, which is going to be like row and column like that. But we can just use RC. So it'll be row and column information. We enter into the grid, and that should return us the character. Okay, so basically it's the same thing except without all that structure. We can do that by we can take the grid line and we can just say flatten. Let's inspect it. Actually, we don't want to do all the way. Let's do just one level of flattening. See if that's what we want. Okay. Okay, so we actually want it to look, I mean, we're going to convert it into a map. So what we want is something that looks like row comma column followed by a character followed by a row comma column and a character like this, and there's a way to convert this into a map. So we should see two left brackets to begin with. So let's see, it has 3, so we need one more. So we'll change that to a 2, and that should be good. Okay, so now to convert this into a hash, we say hash with a bracket. We wrap that up, and this should have a star which turns this list, which flattens it one more time into a list of arguments. Okay, so when we do that, perfect. So we have a hash where we have the grid coordinate and the character. Grid coordinate, character. Okay. All right, so that's the grid. So I'll just put it here for reference. So I say grid is equal to this, and we can take away the inspect. So we have the grid totally taken care of now. Next thing is the word. So if you take actually before we do that, let's finish off the grid by handling the output. This, let me take off the relative line numbering. Okay. Okay, so here you can see that from line 1 through 7, this is actually 1 through 6, this is reading in the input. Now we handle the output. The output, we'll do it by doing grid line each. Actually, we could do a map. I'm trying to write this in a functional style, so I'm not trying to. Normally, when you do things, you would specify a variable in like an iterator variable, and then just kind of like loop through. But I'm going to just try to avoid that. Okay, so this one, this would give you a line of rows. So rows, grid rows. Oh, grows, grid rows. Okay, and that will give you, actually, that will give you a RC, a list of RC followed by characters. Okay, so I'll just call it line for now. Line.map. Okay, this is different from the other line because the line above was for a string. Now this is a list of rows. I'll just call it row line. Okay, so for each of these, when I map it out, it's going to have the row and column information followed by the character. Okay, so then we can say, we can just return the character. And actually, we can just probably do it this way. And we're going to join it by a space. and we join the lines with a new line. Okay, let's print this out. Okay, great. So you can see that the data has been entered in properly because the output matches. Okay. The reason why we're doing it this way is because we're going to have a mark, and that's going to be a list of found coordinates. So for example, let's say 0, 0 was a found coordinate, and that will show up. So here we'll put a condition saying that if, actually we don't say if, we can say mark.include the row and column information, then I want to put in the character, otherwise I'm going to put a dot. So we should see everything as dots except for the upper left hand corner. Okay, we have a syntax error. Oh, that's because we forgot the question mark. Include question mark. Okay, so there's the grid with the U over there. Okay, great. So this is the output now is complete. We should also print out the word S just so that people have a reference. Do a put S. Okay, so people have a reference to what it is that was the input. So this is what our data is going to look like. I mean the output. So we have the input taken care of. We have the output taken care of. We just need to do the find the mark, and we're going to do this in the functional style by like transforming the data. We transform the data starting with the list of words. So word S, that's our starting point. Actually, we're going to comment this out so that we can just concentrate on this, and we're going to eventually transform the mark into what we were expecting, which is a list of coordinates that's row and column, row and column. So the starting point is actually a list of words that look like foo, bar, whatever. And so there's going to be an intermediate step where I'm going to turn that into a list of words. Well, it'll be all uppercase. And then from there, for each of those words, I'm going to convert them into the row and column information of where they're found. And that would be for foo, a list of them, row and column for foo. And there's going to be another one for bar, but I'm going to join them together. So it'll be one complete list, and then I'll do it for the rest. And that's how we're going to turn the input string into a list of position coordinates. So we're starting with the word. Okay, so let's. Okay, first it's completely a string. So we're going to split it on the new line, not new line, comma. Okay, now we have a list of words, but there are two problems with this. One is the spacing. There's extra spaces around here, and they're lowercase letters. So we need to convert that. So I think it's a good idea when we read in the argf right after to convert everything into uppercase, just to make everything simpler. So let's see. And so now everything is uppercase. Let's get rid of the map each one to do a strip, and that should strip out the white space. So our first part is done. Second part now is to actually turn those into found coordinates. Okay, so we're going to do a strip, and actually okay, I'm going to actually turn this into this word.strip. Okay, and it should still work the same, and the reason is because we're going to call search on this. And right now we don't have search, so let's just create a dummy one. Search that takes in a word, and for now we'll just put the word in a list. and then we'll do the transformation. So you can see that that is working properly. Actually, what we want is we want them actually to be joined together. So instead of using a map, instead of using a map, we're going to do a flat map. So you can see that it joins it together. Right now, it looked like it did absolutely nothing, but it stripped away the list. One way is like I can just put a number in here like 12. Now you should see like a bunch of 12s. Okay. So now we're going to take each of those words and convert it into position coordinates. And we're going to pass in the necessary data. So first, we should pass in the grid information. So it has access to the grid to actually search the field. We have the word, but we also need the position coordinate. So it would be good to go through all the position, start off on all the position coordinates. We can do that by starting from here and saying that grid.keys. This will give you a list of all the coordinates, and then you can do a map, a flat map on this. So okay, so when you say the grid keys, you now have a list of row and column coordinates. This is getting a little bit long, so let's break this out. And okay, so starting with the grid keys, you're doing a flat map, doing a search, and the reason why is because you want to pass in the row column coordinates. Okay, so let's put that in there. Word, actually grid, word, row column, and the word. And for now, just to make sure that everything is working properly, I will put in the a list with row column coordinate and the word. And just do like, okay, there's a, let's see, what am I missing here? Oh, the flat map. Okay, so I forgot the end curly. Okay. All right. So far, let's see. Okay, so you can see that it is going through each of the coordinates, and it's also iterating through each of the words. So, for example, the last word here, met, it starts from the 0, 0 coordinate, then it goes to the 0, 1, 0, 2, so far, and it goes all the way to the end. So we have a good starting point. So we're actually done with this part of the code, and we just need to focus on the search. Okay, so let's think about the terminating condition. Well, first, one of the things that we definitely need to do is keep a track of the path of where we've been, because that's going to be the return result, and initially it's going to be empty. So we're going to assume that and we're going to take apart the word. So as we find one of the letters in the word, we're going to take that out of the word so that we can call it recursively on search, and it will find the rest of the word. And how do we know when we're done? We're done if the word happens to be empty. Then we know that we've found everything. So if we have found everything, then we just return the path. Okay, next condition. Okay, and we can actually run this and it still will show you this. The next condition is return nil if, and these are all the bad conditions. Like when do you stop? Well, we stop if we run out of we run outside of the grid area. How do we know that? So if we do a grid on the RC, that will return nil. If we give it row and column coordinates that are outside of the inputted grid information. So so if we're outside, we have to say it's not. Okay, so if you don't have the grid position, okay, that reason to stop. Another condition would be to, if it's a path that you've already visited. So we can say path that include RC. Okay, so if you've already been there before, you can just stop. This is not the correct path. And now we can actually do the letter comparison. So if the word, the first character of the word, if it does not match the grid position of the what's on the grid, okay, your current position, then we know that you can stop. Okay, so these would be determining conditions, and let's think about. Okay, yes, that should be it. Actually, we haven't handled the question mark, the wildcard character. So we can actually what we can do is put that in a list by saying it's a question mark, or it's the grid of row and column dot include. So this is saying okay, so if the word is not a question mark and it's not on the grid in that position, then we can just stop. So this handles both conditions. Now this case, the processing case is what do you do about everything else? Well, you're at a position, you want to go in all directions because we're doing the snaking. So to go through all the combinations, you need to, okay, let's go into a pry. Okay, so if you have -1 to 1, okay, and you say product of -1 to 1, okay, actually this is not correct. We want a list, and a list of numbers, and so you can see this has all the directions. So -1, -1, which means diagonally to the upper left. We also see 0, 0. We're going to keep that in there because if you happen to hit upon 0, 0, that means that you're going to trigger this clause that you've been there already. So it won't even include it. So it's not going to affect the code. So this is how we get the list of all the directions. So let's say that over here we say -1 to 1 product of -1 to 1. Okay, so this gives me all the directions, and I'm going to do a map. So I'm going to convert that into results. So that's the direction. Actually, I can split it into R and C. Okay, so the difference in the row and difference in the column. Okay. So given that, I want to do a search. Oh, actually, I want to do a flat map, because once we get all this data, we want to combine it as if it was just one piece of data instead of a list of data. Okay, so we're going to do the search. The grid is still going to be the same. Now for the row and column, it's going to be different because it's going to be RC0, which is the row portion, and we're going to add the difference in the row. And RC1, that's the column information, and we're going to change it by the column difference. And so this would be the new row and column position in the direction that's being used. the word, we're going to strip out the first word. So we're going to say 1 to -1. And the path, well, we're going to include this path. So it'll be path plus RC. Okay, and close. Okay, this got a little bit too long, so let me see. Let's just put this in a line and close the curly. Okay, so this should be done. Let's see what the mark looks like. Okay, there's a lot of nils. That's because here's the nil. There are places where it's not. There are places where it's empty positions, dead ends. So we're going to say compact to get rid of those. Okay, and see nil. See. Oh, we need to do a compact here because see. Okay, as well. Let's see. Nope. Oh, because this actually returns the nil. Flat map, nil, compact, search. Oh, and we also need to do compact over here. Okay. So we have a bunch of positions here, and we can unleash the output. Okay, and there it is. So you can see that it works now.